OpenShift container storage and the latest release 4.6, and we're going to get a deep dive into that from Marcel. But I thought that resilience probably was the best word to kick off the year 2021 with, because that's when you take the capacity to adapt to change and over a difficult year and come together and make things better and make sure everybody is more resilient. And I think we need a lot of resilience in 2021 and perseverance. So on that note, I'm going to let Marcel introduce himself. We're going to talk for about 20, 30, 40 minutes, depends on how long and how deep Marcel goes. And we will then have live Q&A. So if you have questions, ask them in the chat wherever you are, whether it's in the live stream on Twitch, on YouTube, or here in Blue Jeans with us, or even maybe on Facebook. So again, welcome to 2021. Hope you're all safe and happy wherever you are. Marcel, take it away.
Thank you very much, Diane. Thanks for the introduction. My name is Marcel Hergade. I'm a marketing manager or evangelist for the data services BU. And from that perspective, today we're going to brief you about data resilience for OpenShift, and that is with Redhat OpenShift container storage. First of all, my best wishes for the new year for everybody. I hope it will be a fantastic year for all of us. And for now, we will have a look at what's new with OpenShift Container Storage 4.6. So we'll have a short introduction into Redhat Data Services, what that is about, and then how that relates to OpenShift Container Storage. We will dive into the release highlights of version 4.6, what's specific with this release, what the theme is. We'll dive into some other new features with this release, and we'll have a glance at the roadmap. So this is the agenda for today. First of all, let's have a look at data services. What's data services about? We offer data resilience for OpenShift with container storage 4.6, and the whole goal is to make data accessible to applications across hybrid cloud, unlocking the power in new and impactful ways. And this enables for innovation without limitation. So the messaging here is actually simplified access, so easy to access, a consistent experience no matter where you run, if you run on a public cloud or on-prem or virtualized or on bare metal, it's all the same consistent experience. It doesn't matter where you run. And it's a dynamic scale, so that means that the system is very dynamic and can adjust to your needs. With data services, we have a different mindset. First of all, let's have a look at the traditional static approach as it always was in the earlier days. There was also always a focus on improving efficiency to get things better. It was more or less an infrastructure up view, so we always looked at these things from the infrastructure side. Poor performance at scale, so when the system needed to grow and scale out, then this had performance penalties, because there were limitations with scaling, and you had walls that were hit at some point, and you needed to be flexible with these things, and performance issues applied. It's disconnected, so it's not always online. It's a specific a setup that sits somewhere in a data center, and it's not per se connected to the internet. So therefore, it's manual, monolithic, and rigid actually. And if we look at the new approach, the data services approach, there's a focus on innovation. And we don't look at it from an infrastructure view, but we look from the application side, so application oriented. It needs to add benefits to the application, and it needs to be highly scalable. Because if you need to grow, then your data services and storage also needs to be able to grow. always on, so always available, and automated, on demand, and flexible. So you don't want to wait on an administrator to fix things for you if you need some adjustment or so. It's entirely automated. So what does that mean for developers and data scientists? First, let's have a look at the traditional approach. And then this is a comparison with a library where you can actually go for books. You must go there. You must visit that library. And there's a limited range of content on offer. So not everything is per se there, but it's what they have that's available. You can only check out a few items each time. So when you come there, you can only take a few books with you. You cannot take the entire collection. And there's a line to check content out. So you need to get in the line, check out, and there's a limited usage. So you can keep those books for a limited period of time, and then you need to return them. Or you must revisit the library to renew your books. Let's have the same comparison, but now from a data services approach. With data services, you have access to your data from anywhere, no matter where you are. There's a wide range of rich content to offer. It's not limited to just a certain collection of content. And you can have simultaneous access to all the content. So with multiple people, multiple users, you can access the same content. So it's not limited to one user that has access at a certain moment in time. And self-service, so there is no need for a manual supervision by some administrator who needs to fix things for you. There's an unlimited usage, and access can be granted indefinitely. So as you see, there is a lot of benefit here, but it also means a different approach. And this is typically the difference between traditional static and the data services approach. Well, let's have a look at Redhat data services. Where do they fit? So we have the Redhat OpenShift container platform that sits on an infrastructure, which can be public, private, or an edge environment where OpenShift container platform runs on. It consumes storage, whatever storage is available in that infrastructure platform. Then on top of OpenShift, that's where Redhat data services sits, and that serves to the applications. We'll go into some more detail there. If we compare this to the old school OC model that was being used in the network world, then you can see that the underlying storage, which is available in the infrastructure, is the physical storage, the so-called layer 1, so the physical layer. Redhat data services is higher up in the stack, and that's actually the presentation layer, because it doesn't source storage, but it actually provides storage services. And that is what Redhat data services does for you. So you're not selling a storage product as such, but you're selling storage services, data services based on storage. So if you are in a situation that you already have a storage system or have some storage environment, that doesn't mean that you cannot use data services, because that's higher up in the stack. So you can still leverage Redhat data services, and this presentation will explain why it makes sense. Redhat OpenShift container storage consumes storage to provide higher level data services. And this is very important to realize, because it's not a storage product as such, although it has storage functionality built within, but it always consumes existing block storage. Well, and then that existing block storage, that can be Amazon storage, AWS block storage, it can be Azure, Google Cloud Platform, but it could also be storage sourced from VMware by a Sun or a vSun, or maybe local drives, direct drives, and it can even be a local drive in a bare metal system. So that's the storage layer. On top of that, that's where Redhat OpenShift sits, and on top of that, that is where Redhat Data Services resides, which uses Redhat OpenShift Container Storage version 4.6, and with that, you will get a uniform Kubernetes RWO and RWX storage class. Multiple storage classes are being sourced from that single storage below the infrastructure line. I hope this makes sense. We add a lot of functionality just on top of storage. So your existing storage is most likely block storage. On top of that, there's Red Hat Data Services with OCS 4.6, OpenShift Container Storage 4.6, and that one serves you with file storage, block storage, object storage, S3 compatible. So there is a lot more on top of that, and that's what we call Red Hat Data Services. And this is a kind of new vision, because with data services, we divide this in three main pillars, actually. So we have data at rest, and data at rest is more like data in databases, data warehouses, data lakes, and so on. So that's data that's being stored in a database for use. It could also be MySQL, SQL, CrunchyDB, DB2 warehouse, for instance. That's data at rest. The second one is data in motion. And with data in motion, we mean streaming data and like messaging data, Kafka, AMQ streams, serverless, Knative, functions, server functions. That's data in motion. And then finally, we have data in action, and data in action means that's where data is actually being processed, like data analytics, data intelligence, AI/ML, Starburst, Jupyter, Jenkins, TensorFlow, those kind of things. That's what we call data in action. So data at rest, databases. Data in motion is streaming and messaging, and data in action is where data is actually being processed. So these are the three main data services that we actually recognize with OpenShift Container Storage in Red Hat Data Services. So speaking about Red Hat OpenShift Container Storage, what does it actually provide? What does it offer? So it offers you persistent storage for containers in all flavors, like block storage, file storage, object storage. And with file and object, we can provide persistent storage for containers. It has a full integrated management from within Red Hat OpenShift. So there is no separate console or no separate way of managing Red Hat OpenShift Container Storage. It's all built in Red Hat OpenShift. There's an entire integration. And it offers storage provisioning, like I said, for all types of data, block, file, object. And it's all OpenShift operator based, so it's a very easy setup. It's no difficult process to set it up. Everyone can do this, actually. So to summarize this, with Red Hat OpenShift Container Storage, it runs on OpenShift, it integrates with OpenShift, it serves any type of data service, it runs on any cloud, on a public cloud, private cloud, on-prem, virtualized, whatever, bare metal. It's a consistent experience, regardless of the underlying infrastructure, and it's all used and managed through OpenShift. So no separate consoles, no difficult things, easy to install and easy to work with. The key use cases that we see with our customers are these like cloud native apps, CI/CD repositories. That's where this can really be helpful, but also structured data like databases and data warehouses. And we have a very nice example of IBM DB2 warehouse, where actually OCS is being used and had really great results. Another use case that we see often is big data, data analytics, AI/ML, where Red Hat OpenShift Container Storage can also serve as a data lake storage, where you can gather all your data and that multiple applications can access the same data without having to move data around, or you can have multiple data sets available within the same system. So now let's go to the details, to the release highlights with Red Hat OpenShift version, Container Storage version 4.6. And the theme of this release is actually data resilience for OpenShift. Well, what does it mean? We offer resilience, data resilience for applications that run in OpenShift. And how does that work? I created this little word cloud with a lot of words and terms that you might hear or have seen somewhere, and let's go a little bit into more detail here. So the new data resilience features with OpenShift Container Storage 4.6 are all built on open standards. So it uses the Container Storage Interface, also named as CSI, that comes with OpenShift. With that, we can actually create CSI-based snapshots on the storage. And we can make use of OADP, and OADP is OpenShift APIs for data protection. We will go into more detail on this later on in the presentation, but just for you to know that we use open standards, so no proprietary stuff. It's all open standards being used here. And what we deliver is a container-aware data protection. So that means application persistent volume level backup, so protection of the persistent volume level. But that's not really special. What is special here is that we do also cluster protection on a namespace level. So just creating a data protection or a backup from your persistent volume is nice, but that doesn't mean that you have an entire capability to restore everything, because you need to know the correlation between the volume, between the container pod, but also the metadata around it, where it makes sense to the container, the settings, the specifics of the cluster. So what I'm trying to say here, only the persistent volume level backup may not be enough. So if you need to do a disaster recovery, you also need the other information to make the container run again, to have everything at hand, and even you can restore across multiple OpenShift versions. It will also work alongside existing data protection solutions. So it can use your existing backup solution, where OCS orchestrates the container backup by working through the container storage interface. There's no need to replace your existing backup software, so you can reuse what you already have in the house. So let's have a little look on how this looks like, what this looks like. So in the traditional world, the traditional model, we had a server that ran applications, that had state, was connected to some external storage, and that's in the live situation. Then if you would want to have data protection on that same, so we then created a backup. For the server itself, for the operating environment, that's where we mostly use the server image. So you could restore an image to get the operating environment back. But then you needed to have the state, and the state is the installed applications, the settings of those applications, those kind of things that need to be restored from my backup. Third, you wanted to back up the storage, because the storage got actually the application data. So where the server got the operating system and the applications and the state, then the data of the application would be in the storage. So those things were considered in a backup altogether, and that would enable you to restore the entire system. Now, there was the shift to the container platform. In this situation, there was no server state anymore, no operating system backup, because a container platform could run anywhere. It was simple to rebuild it, to just build a new container platform, and the containers run from an immutable image that came from a registry. So as long as you had access to the registry, you could rebuild the platform, run the container once again. So there's no need for an operating system backup, for a state backup in that regards of the applications. The containers, of course, had state, and this state was captured in a persistent volume. So that persistent volume that lived on external storage, and that storage also needed to be backup to make it back available in the case of disaster recovery. And then you need to be aware about the correlation again between the container and the persistent volume, because if you just restore persistent volumes, you never know which container belonged with which volume. So that's also something to take into consideration. So that was a kind of difference. And now with OCS 4.6 and data services, this changed around. Now we can do a save state of the entire platform. So that means we can save state the container platform, the specific settings that are relevant for the container platform. We also save state the storage, platform metadata. So that's all in the backup. And this means that you now can do an entire restore to another cluster, for instance, or even to another OpenShift version. Because you have everything that's needed to recover, to bring the application back online again, including all the namespace details. And to make it even more interesting, we can do this with OADP, which provides APIs to backup and restore OpenShift cluster resources, so YAML files, specific files for a namespace, internal images, so that the images that are needed to actually to start the application, but also the persistent volume data. So this all together is being realized within this data protection mechanism. So that's done by OADP, which is currently working with IBM Spectrum Protect Plus as a partner application that has this enabled. So what does this mean actually? We work with several partners, of course. We have others where we work with. For instance, we are also working with Kasten and Trilio, and there may be other applications in the future that will work with this and support this. So this is a flow chart. On the left side, we have the container platform and the storage. Your data protection application with OADP enabled, we go into more detail later on this, so don't worry if it's a little bit too much. But your data protection application that supports OADP, that will reach out to your container platform cluster by leveraging the OADP API. And it will take a backup of the containers, of the storage, the states, the system information, namespace information, and that information will all end up in a complete data protection on the other side. So with that backup, we can restore to the same cluster, to another cluster. We can reproduce the same information very easily without difficult interaction. And if you want to see this live happening, I have my colleague Annette Kluet. She created a nice video that actually shows how this process works in real life. So on this slide, there is a link, and I will share it, of course, afterwards with you. And if you go to that link, then you will end up in a video where very detailed is shown how to do this and how it works and what it delivers. I hope it makes sense. So just to give you a glance of what's possible here. So with OADP, you can use what you already have. It works with your existing data protection application. It orchestrates container backup with OpenShift container storage. You don't have to worry about snapshots and so on. It's all being abstracted away by OADP, which integrates with your backup application. It provides application consistency versus crash consistency. So with just a snapshot, you would have crash consistency. And with OADP combined with your backup application, that's where you can have application consistency. This also results in a reduced need for training because you can use what you already have. You don't need to use some other backup application or some other data protection application to realize the same. No, you can just use whatever is already there in the house. And it therefore doesn't require additional monitoring because it's already integrated. It uses OpenShift and it uses whatever you have already. So what is OADP? It's an OpenShift API for data protection. It's a set of APIs, and it's a Redhat supported community operator that provides APIs for backup, restore, scheduling, backup storage location, and snapshot location. So this is all done by OADP, and I said it's a community operator. So this one is supported by Redhat to ISVs. So backup vendors and backup partners can actually use this and get Redhat support on it. So you're fully supported here with this mechanism. So let's have a closer look into this, how this works. So with Redhat OpenShift, you get CSI, so the container storage interface, which is a standard mechanism of accessing container storage, CSI. Once we have Redhat OpenShift running, we can do an operator-based installation of Redhat OpenShift container storage, which has support for CSI, snapshots, and clone. So this is a really simple installation. Right-click, install, and then you do a little bit of configuration. That's not that complex, so it's easy to get it all up and running. And once it runs, you get a very nice marriage of the both. And that means that you have a single interface to work with through CSI. So you're working with the CSI interface within OpenShift, and that one attaches to Redhat OpenShift container storage and makes it possible to create snapshots and clones without having to go into all details, without having to go under the hood and do ceph commands and so on. It's all abstracted away, and it's all running through CSI. So this is to show you how you have a fully integrated management within the Redhat OpenShift UI. And if you use your backup application with OADP, it makes it very easy to work with this combination. So with an OADP enabled backup application, and at this moment we have IBM Spectrum Protect Plus who can actually do this, then it really works very simple. It just addresses the CSI interface and it will work with its APIs to make the whole thing running without having to go through difficult details. And then your question may be, yeah, hey, that's nice, but I don't have IBM Spectrum Protect Plus. What else can I do with my other application? Well, with any other backup application you can use with, at this moment, you can use with pre and post scripts, and that's a script that you can run in the backup application. Pre means before the backup starts, you can do some interaction with CSI, so you could request the storage to create a snapshot, and then mount a snapshot to the backup, create a backup, and afterwards, post script, afterwards, remove the snapshot, for instance, after it was backed. Sorry. So this is OADP abstracts all this complexity away. If you have a backup application that can use OADP, if you have another backup application that is not yet OADP enabled, then you can use with pre and post scripts and address this against the CSI interface on OpenShift. So either way, you can have a nice solution to do your container backup, but also other relevant information for your cluster to be able to restore. So let's have a look at data resilience service level objectives. At this current release with 4.6, we have support for the backup solution enablement. So that means actually protection against logical failures. Something like user errors, accidental deletion, bad actors, application software bugs, things like that, hijacking software, malicious software, virus. So you can restore data that was captured in your backup. It's a restore to a previous point-in-time copy, and it's based on a snapshot, and the snapshot can be local or remote. So this is supported right now. In future releases, and that's on the way later on this year, we will also have a one disaster recovery solution, which is actually protection against data center disaster. That means that it's a replication, asynchronous replication to some other sites, which actually protects you against data center disaster. Think of failures to power grid, geographic, skill, natural disasters, etc., those kind of things. Then you can have another copy at another data center available. And then later on, we will have a Metro HADR solution against protection against hardware failures, hardware components, system wreck level, etc. So this is all to come in future releases of OpenShift. It's planned for the next release and onwards. So for now, we have full support for the backup solution. And in the future, you will always also have a replication, asynchronous and synchronous replication planned for the next releases of OCS. This all makes sense in regards to RTO and RPO. RTO is recovery time objective. That means the time it takes to get back to that a certain point in time, application downtime. And then there's RPO, recovery point objective. And that means how the more we can go to the right, the less time is needed to get to the point of disaster, actually. Recovery point objective. So for now, logical failures, so support for backup applications, future release coming soon, asynchronous and synchronous replication. So this is on the roadmap for next release. Then we have some other new features to walk through. So this was the main theme, data protection, data resilience for OpenShift applications by offering a capability to create CSI snapshots, CSI-based snapshots. So without having to go through all the difficult details, you can just address the CSI interface, and that one will take care of all the complexity and will make sure that the snapshot or clone is being realized for you. But it's not the only thing that comes with OCS 4.6. There are some other features, OCS snapshot and clone. That's what we already spoke about. What I didn't tell you is that it's also possible to do the same from the OpenShift UI. So within the OpenShift UI, you can also create snapshots from there. So even if you don't have a backup application externally that does this, even through OADP or through scripting, you can also do it yourself in the OpenShift UI GUI actually. Then another thing is encryption at rest for the entire cluster. And this one uses Ceph encryption. Ceph is under the hood for this encryption, and it goes for the entire cluster. So this is good for if you have failed drives or so, whatever, that no one can actually access that data because it's encrypted. Multi-cloud object gateway namespaces, that's a whole mouthful, and I will go into a little bit more detail in the next few slides. Same for multiple storage classes. So we now have a capability for multiple storage classes to enable new functionalities, local storage operator announcements, and improve bare metal deployment. So little more detail. Encryption at rest for the entire cluster. It means that all your storage devices use a self-generated encryption key and are encrypted on OSD level. And this again protects against disk theft and allow safe RMA of filled local storage devices. Your data is protected. No one can do anything with it without having access to the key. Then multi-cloud object gateway namespaces. This is also something that needs a little bit explanation because this is actually a proxy bucket that does not contain, this is about object storage, of course, and it does not contain any objects. It's just plain text. It connects to existing buckets, which may reside on Amazon AWS or Azure Blob. So it will provide you with an aggregated view of all these object resources. So you can have multiple locations where you maintain object buckets, and this will give you an aggregated view across all these buckets that live on different locations, and you can configure a default writer. So that means that anything you write will go to a specific location, but everything you read can come from multiple locations. And this is very handy if you would want to do a migration from one platform to another, where you still have access to existing data that lives on the old platform while you're already working on the new platform or in the other situation. In this example, it's public cloud, but it could also be, of course, another data center, a private data center or whatsoever. So this is what multi-cloud object gateway namespaces does. Federated view across multiple bucket resources. Writes go to a specific location that you configure up front. And the purpose of this is data migration or things like that. Multiple storage classes are here to introduce new capabilities. And an example of such a new feature could be replication count 2. And maybe you ask yourself, what's this all about? By default, we have replication count 3. So everything is written 3 times into OpenShift container storage. And with replication 2, we can reduce that replication to 2 times. And this is specifically handy if you're working with applications that already have their own internal replication mechanism. So certain applications already have internal replication. And if you then would store that on OCS, then it will still get replicated 3 times. So you will get replication on top of replication. And to reduce that burden, we can lower this down to replication count 2. There will always be a need for some replication because replication 1 means none. So if anything goes wrong, then you will be doomed and lost. So therefore, replication 2 is the minimum that we absolutely need. But it's better than replication 3 if you have an application that already has its own internal replication. So I hope this makes sense. And then compression is another feature which you would want to enable on a certain storage class. So the compression gets enabled on a storage class. So hence the need for multiple storage classes. So you can have your default storage class that is replication 3. You can have a separate storage class that is for replication 2, where you can assign your replications to, or have a separate one for data compression, which leads to data reduction in the end. So that's about the multiple classes, storage classes. The container snapshot and clone, we have already been going through this more or less. So I'll leave it to here. You can use the API directly. You don't need specifically a backup application, but if you have one, you can easily interact with it because it's all open. Another announcement is the local storage operator, and with this, it makes it very easy to create an automated listing of candidate disk devices. So suppose you're on a virtualization platform or on a cloud platform where you want to use SSDs attached directly to your instance or whatever, or if you use bare metal with multiple disks in the chassis, then you will get an automated listing of whatever is available in regards to disk devices, and you can make them easily usable for deployment with OCS, OpenShift Container Storage. Full automated discovery without having to go through disk discovery steps outside OpenShift. So, go on the command line and see whatever devices you have. This is all abstracted now in the local storage operator. So it makes the life of an admin somewhat nicer and easier again. Then there is an improved attached devices deployment. This is a result of that improvement of the local storage operator. And this brings us to tech preview features. Tech preview features are features where you have early access to things that are being developed with Redhat. It's not specifically meant for use in production. If you would have a specific need for production use, then you can always reach out to us, and so that we can see if we can work with you on an exception basis or if possible. But this is tech preview. That means you can test it. It's not per definition suitable for production uses. So one of these features is auto scale of object gateway endpoints. And this is all being addressed by OpenShift functionality. So you can scale your endpoints, S3 endpoints, to improve the performance. There is also a support for OpenShift Container Platform compact mode for edge situations, a reduced platform footprint for specific situations. Let's just go through them quickly one by one. So the multi-cloud object gateway auto scale of S3 endpoints and performance. This is done by OpenShift auto scaling, and that actually creates multiple endpoints where needed so that you get a better performance. Compact mode is something that's where you run everything. So where you run OpenShift and OpenShift Container Storage all together on a 3-node cluster, just 3 nodes. So this is meant for proof of concept demonstrations or for edge use cases or specific use cases where you don't need that much on hardware resources. That you can use the compact mode where it runs the entire system on 3 nodes. So that goes for the OpenShift platform, but also for the OpenShift container platform with everything within. Only 3 nodes are required here for a smaller footprint. Then another thing that's in tech preview is support for expanding your OpenShift storage capacity. Multiple backend storage classes. Well, what does this mean? We have customers that use the VMware infrastructure, and these customers often deal with data stores of 4 terabytes within VMware. As a kind of common practice in VMware, they use 4 terabytes data stores. Now we can use multiple of those as a backend for OpenShift Container Storage. So this is also something that's in tech preview, which makes the life of a VMware OpenShift user somewhat more easy. The reduced footprint, once again, can run on nodes that have 8 CPUs and 24 gigs of RAM. Again, for the edge and smaller use cases, proof of concepts, this is where you can work with limited hardware resources. Finally, support for IBM P and Z platforms, so we can now run OpenShift and Redhat OpenShift container storage on these platforms. And this is tech preview with this release 4.6. For the people who are interested in this, it's now possible to run this application together on these platforms. Then we have reached the point of the roadmap. So 4.6, this is where we are right now. This has been released on December 17 as a kind of pre-Christmas present, and the full official marketing launch will happen soon. It's planned for January 19, so expect more to come. You had just had a sneak preview on what's coming along and what the highlights are. So with 4.6, main theme is the snapshots, CSI snapshots, data resilience for OpenShift, backup partner-based solutions, and the 3-node cluster. Those are the main highlights here. 4.7 will have geo-replication, asynchronous replication, synchronous replication, stretch cluster, and that's to be expected in future releases. For today, this has been my story, my presentation. I hope you enjoyed it, that you got a little bit insight on what's new in 4.6. If you want to have more information, you can visit our websites, www.redhat.com/dataservices or /storage. My name is Marcel Hergaarden. My email address is here and below. Feel free to reach out if you want to know more, if you have questions or specific you want me to address offline. And if there's anything that I can answer right now, I'm happy to. Thank you.
All right. Well, thank you, Marcel. That was a tour de force. And yeah, definitely if you're looking for a demo on this, Annette Cluett has done the IBM Spectrum one, and we already threw the link to the YouTube video here, and we'll add that in when we upload this video. There also was previously an OpenShift Commons briefing on the OADP operator using Ceph CSI. So there's a lot of good content out there as well. So we just keep getting better each release. It's quite wonderful to see. There is a question from one of the folks out there in the live stream. Is there any documented way to deploy OpenShift 4.6 control nodes and compute nodes into separate VLAN?
I have to ask that, address that with product management. I don't know that by heart yet, but we can get back to that question later on.
All right. So if you find an answer to that, just shoot it to me, and we'll shoot it out there into the universe.
Will do.
Yeah, and Michael St. Jeans and a few other folks from Redhat are also online too, and they were mentioning that Trilio and Kasten use their own APIs to deliver a solution in addition to the IBM Spectrum one. Have you used either of those yet? Have you seen them in action? Are they production ready now?
IBM Spectrum Protect Plus is actually ready, and it's there. It's also visible in the video how that works. The team is working on the other solutions, and there will be white papers and briefs about that also with our launch planned for January 19. So expect more to come there, and it's expected to be available for production use by then, because we have all the information out there and documentation.
So I'm looking to see if there's other questions. There was one question, but I'm pretty sure you answered it, was what was the difference between how's what you're doing different from just using persistent volumes and persistent volume claims, and I think you went over that pretty well in the slides. But is there anything you'd like to add to that? Pretty generic question.
I don't see the question here on my screen, but the main difference is if you do a backup of a persistent volume, then it's only the data in that volume, but not the specifics of the container by itself. So no information about the namespace, no cluster information, specific YAML information about that container pod or the namespace where it lives in. So that's the main difference, so that you here get an entire data protection of all the relevant information, including the images that those containers require to get started. instead of having just the persistent volume data as such. I hope this makes sense.
Yeah, no, it does to me. And I think you kind of covered that in some of what you were talking about earlier. So I hope that did. There's Keith is online right now, and he's saying that there is a link. If you look in the chat for the VLAN, there was some in docs, openshift.com. There's some documentation there on the container platform for 4.6. So that might be a place to look for the answer to the VLAN question for folks who are looking for that. So I think I'm thinking that you might have answered all of the questions that you can at this point. I know one of the things that, because I also, tomorrow is the first OKD working group meeting for the session, and one of the things that we're trying to do is make sure that all the community operators, like the OADP included, work well with OKD. So we'll be talking about this again tomorrow at 9 a.m. in the OpenShift open source side of things, making sure that it works with OKD 4.6 and the latest release of that. So I know we're working very carefully to make sure that all of the community operators that are available in the commercial offering of OpenShift are also available and working well with OKD itself. So there's lots of moving parts to all of these releases, and we're really pleased that that you've come and kicked us off for 2021 with this topic, because it's near and dear to my heart, especially because it's leveraging some of the community operators. So I'm giving everybody a few more seconds here to see if there are any other questions or any final words, Marcel, that you'd like to add in.
Yeah, I think this was pretty much it for today. As I said, we'll release officially January 19th with all the information that will come available then. There is a full press release with analysts and a press worldwide. So it will be a big release of Red Hat OpenShift 4.6 and all in the context of Red Hat data services.
Yeah. So we'll look forward to that, and we'll have everybody back again probably right shortly thereafter to do some more demoing. And so I'd like to just thank everybody for coming on today. I know it's the first day back to work for almost all of us, except for those of you who are covering us on the holiday break, which we are grateful for. And look forward to doing more of these briefings in 2021. And if there's a topic that you're interested in, please reach out to me. I'm easy to find at OpenShift Common on Twitter, or my personal Twitter handle, which is just Python DJ. Just DM me, and I will coerce someone along the lines of Marcel or external to Red Hat and grab them and make them give us a talk on whatever topics you're listening for and looking to get more insights into. So Marcel, with that, I'm going to say thank you very much and have an absolutely wonderful 2021, and take care, everybody.
Thank you very much, Diane, and the same. Thanks.